In this tutorial, I'm going to demonstrate how to use LCD Composer, which is a Python program I wrote to identify low complexity domains in protein sequences. Now I'll be running LCD Composer from the command line, so if you're not familiar with the command line, I made another tutorial video that's linked on the LCD Composer GitHub that I would recommend watching first. This video also assumes that you already have Python 3 installed on your computer. If you don't, I've included a link to the Python download page on the LCD Composer GitHub page. Okay, so I've downloaded the LCD Composer script as well as a series of test sequences that I want to analyze using LCD Composer, and I've navigated to this location via the command line. In the first example, I'm going to search for Q-rich low complexity domains using default parameters in LCD Composer. So the command for this search is to type Python and then a space and then the name of the script, so lcdcomposer.py, and then another space, and then the name of the file that contains the sequences that you want to analyze. So in this case, testsequences.fasta. Just note that the extension on your FASTA file might differ from this, and the way to tell is to go to your sequences file, right-click, and go to Properties, and you can see right here, .fasta is the file extension. So the next thing we need is the name of the results file. So again, we're going to include a space, and then we can name this whatever we want. In this case, I'm going to call it testqresults.tsv. This can also be a .txt extension, but LCD Composer will be outputting a tab delimited file. And then the last thing we need is the amino acid that we want to use in our LCD search. And we'll specify that using a space -A, which stands for amino acids, and then the amino acid as a single letter abbreviation that we want to use in our search. Now when I hit enter, LCD Composer will display the start time, a few progress benchmarks, the end time, and we can see we've created a new results file over here. Now if I open the results file in Excel, we can see the runtime parameters that were used by LCD Composer during the run. And then we have a few columns here that contain the protein ID, so this is the name of the protein that contains the low complexity domain, the actual sequence of the low complexity domain that was identified. We have the location of the low complexity domain within the protein sequence. We have the composition of the amino acids that we searched for within the low complexity domain. And then we have the linear dispersion of the amino acids that we searched for within the low complexity domain. And then the final columns contain the percent composition of each individual amino acid within the low complexity domain. Now, not all computers default opening TSV files in Excel, and so if you're unable to do that, you can do that from within Excel by going to the File menu and then Open, and then finding your file and opening it from within Excel. Okay, so that demonstrates how to do a simple single amino acid search with default parameters using LCD Composer. In the remaining examples, I want to demonstrate how to use the customizable parameters in LCD Composer to do more refined searches. So let's say in the next search we want to look for regions that are highly enriched in aspartic acid. So the command for that might be Python lcdcomposer.py, and then the name of our sequences file. So all of this so far is the same as the last command. Now it's important this time to specify a new results file name. So this time I'm going to call it testdresults.tsv. We need to specify the -A flag to specify our amino acid, in this case aspartic acid. And now this time I'm going to change the composition threshold. I'm going to increase it from 40%, which is the default, to at least 60% aspartic acid. And to do that, I use a -C flag, which stands for composition, and then a space, and then a number between 0 and 100, which represents the minimum composition of the amino acid I'm interested in. Now, if I hit enter, LCD Composer runs again, and we can see a new results file generated. I won't open each results file from now on. I'm just going to show you a few other commands that can be useful in customizing LCD Composer parameters. So let's say in the next example, I want to look for low complexity domains that might be enriched in more than one amino acid. For example, we could have low complexity domains that are enriched in glutamic acid and lysine. A command for that could be Python lcdcomposer.py testsequences.fasta. Again, this is all the same as the previous commands. And again, we want to name our new results file something different. So I'm going to call it testekresults.tsv. And now we specify the amino acids. And since we want to consider these two amino acids together, we specify them without an underscore delimiter. And then let's say we want to set the composition threshold to 50%. So what this means is that we want to search for low complexity domains that are enriched in E and or K at least 50% total composition. So if I hit enter, we see LCD Composer progress, and again we see a new results file here. Now for the last example, let's say we want to look for low complexity domains that are predominantly enriched in Q or N residues, but have some tyrosine content. So a command for that might be Python lcdcomposer.py, and then the name of our sequences file. And then this time I'm going to name the results file qny results.tsv. Now this time we want to specify different composition thresholds for the different groups of amino acids. So we can do that by saying -a qn, but this time we use an underscore delimiter between the qn and the y. And this tells the program to treat these as separate groups of amino acids. Now we have to specify different composition thresholds for the different groups of amino acids. So let's say we want the minimum qn content to be at least 40%. And again, we use an underscore delimiter. And then let's say we want the minimum tyrosine or Y content to be at least 10%. Now I'm also going to show you a couple of the other parameters that we can customize in LCD Composer. One of those is the window size, which is specified by the -w flag. And let's say we want to specify a 60 amino acid window size. The default window size in LCD Composer is 20 amino acids, so this is a bit larger than the default. And then finally, let's say we want to ensure that the amino acids that we're interested in are more evenly dispersed throughout the low complexity domain sequence to be considered. So we can specify that with the -d parameter, which stands for linear dispersion. And the default in LCD Composer is 0.5, but let's say we want to bump it up to 0.6. So in short, this command should look for relatively long domains that are at least 40% Q or N and at least 10% tyrosine. And now if I hit enter, we can see LCD Composer runs, and again we get a new results file. All right, so those are all the examples I was going to demonstrate. If you'd like to see additional examples, there are some listed on the GitHub page for LCD Composer. There are also additional examples in our publication, and I'll put a link to the publication in the description down below.